Cool. 1089, duplicate zeros. Given a fixed length array or of integers, duplicate each occurrence of zero, shifting the remaining elements to the right. Note that elements beyond the length of the original array are now written. Do the above modification to the input array in place. Do not return anything to your function. Uh, okay, I mean, it seems pretty okay. Uh, yeah, I mean, I guess you just kind of do what they tell you to do, I think. The tricky thing is kind of obviously how to do it, and the naive way is probably like n square, and where n is 10,000 is kind of a little bit annoying too. Do I would probably just yeah, I'll use the two finger algorithm, where but backwards, so then you can kind of figure out that way. Um, maybe is that real? I mean, it is an easy problem, so it should be okay. Uh, but okay, I guess I could have just done this, but um, I'll put no. Oh, because you're supposed to modify the thing in place. It's a really weird problem to set. I mean, set up, but no, that beyond the okay. I mean, this one's not changed. Uh, hmm. I'm just trying to think what is in the spirit of this problem. I mean, yeah, we can do it in place, but is it like, yeah, like if I use all of n additional space, is that good? Probably not, right? So, um, okay. I mean, I think looking back, yeah, I think you do. Uh, oh, thanks, John. Yeah, I was just about to bring that up. I think you just kind of go through it all to count the number of zeros, and then work your way back to do the math. So you switch forward one, two. I guess it doesn't matter if you go forward or backwards, and then you work your way back, keeping track of the number of zeros you have up to that point. Uh, yeah, okay, something like that. I mean, I think they might. I think the thing that I'm thinking about is that like there's probably or a lot of possibilities by off by ones, but you just have to do what you have to do. Okay, let me give it a try, and then we'll see. Um, there's some weird. I mean, not maybe weird, but I just have to think through what edge cases. This is not quite right, obviously, but we do something maybe, but something like that. I guess there's no return value, but so something like that ish. But But there are a couple of places where this is just wrong in general. Don't theory, that should, I think this invariant's a little weird in this context, but zero count is strictly always going to be less than I in theory, so I think that's in theory okay. Okay, well let's just run it. This might be after. This may be afterwards, but okay, maybe not then. Oh wait, she doesn't know if I want to move. Oh yeah, something like that. Well, that didn't work at all. Okay, so let me. So there we go. Okay, so it's a little wrong. It's right here. Okay, I just need another flag. I've been lazy about it. But something like that. Yeah, that's still a little bit weird. Now it's off by one or the other way. Well, okay, let me step back and think about what is it I'm actually writing then. Okay, so here there's 3. So this goes 1, 2, 3. Oops. Oh, let me run this first. That's not right. What am I doing? It means this should be actually something like this. I think it's actually more accurate. I think that's probably why. But clearly this is yeah, okay. And now this gets out of bounds, so if man, this is one infinitely. Nope. Oh. Is this right? Yeah. No, this should be I. So you start the actual and with the extra zeros. I mean, you don't update this per se, but maybe I just needed another variable, and I'm not been trying to squeeze too much into one variable. This is right. Should be okay. Oh no, this is gonna quickly work, but then this never decrements. Yeah, okay, I just need another second variable. I'm just okay. Yeah. Just step back and visualize this a little bit. What am I doing? Okay. That's how you do this. What? Still? Man. No, that's clearly not right. Because this keeps on referencing the same one. Oh my god. Now we need to keep track of the zeros beforehand, but so if the last digit is 0. Because so what's happening is that I is decrementing and then so count also decrements. Maybe this. So that's why it's always look at the same number, but but now this may be skipping this a little bit. So the problem is now it skips ahead a little bit. So I guess you need another 0. Okay. Right. I think I'm just making it too complicated. So basically, what I'm trying to do is given an array that's like this. Now we add the 0. And then just chop off the last. And so we're going to chop off the last 0 count ones. Yeah, that shouldn't be that bad. Okay, let me just rewrite it then. And by here. Okay, that's right. I guess I don't decrement 0 count until okay. So I think what I've been doing is conflating the chopping off part and then the look forward part. That makes sense. Okay, so I guess I could do that. Doesn't seem like I changed much. So this should be right, but then we need this to also. Okay. Cool. Yeah, so I think lesson here for me is that I was probably a little too arrogant. I thought I could keep all the states in my head. I think I just kind of forgot this one point, example where you just have to kind of make sure your two finger algorithm is, well, your two fingers are in the right place. And I was trying to do too much. I think on an interview, make sure you use the whiteboard or piece of paper just to make sure you visualize everything, and what you think is the question is the question. But generally, otherwise, this is pretty straightforward, even though it's a little weird problem. I think you just have to kind of keep your indexes right, which is the entire problem. I don't think there's any confusion about this, other than maybe a quick initial, just like knowing how to go forward and then backwards. But yeah, it is an easy problem, though, because a lot of people hate it for some reason.